Good morning, good day, good evening, wherever you are on the planet. Today's session is about daily monitoring is the first line of defense. We are three presenters today. My name is Carsten Rasmussen. I have worked many years on mainframe platform with parallel sysplexes, DB2 data sharing. My co-presenters are Elden Forbing from the Norske Bank, Norway, Arne Nielsen from Posten in Norway. I'll start this session about telling you a bit about processes. And for that reason, we take a look at this slide here. We have a huge amount of technical data coming into us when we're talking about analyzing SMF data on a mainframe platform. Sometimes hundreds of gigabytes, even terabytes of data coming in. Looking at all the gearbox picture there, it's the machine room. It's where we take in this huge amount of raw data and make it into information. For this, we have a big number of rules, metadata, things that makes the machine room works in a way so we consolidate this huge amount of data into a few gigabytes of information that we need further on. When we have enriched these data with business mapping, meaning that we tag the data so it can be used later on for grouping data and information for business, IT, finance, and others. Now, we have done a lot about the data. Now we need to present all this data. Present it in a way where we have to think of who's going to receive the information. We're looking at operational, meaning technical data. We're talking about the tactical level, the way we see trend and directions. And we also see the strategic, where we have high level of information for our stakeholders, management. And in the end, at the end of the day, it's all about return on investment. It's all about that we take a fair amount of work doing this, but the outcome is that we provide information for different levels in the company. This is what happens in a daily processing in IT business intelligence. So where are we placed? We take a look at the different platforms. We have the Windows environment, we have the ZOS, the mainframe, and other sources where we put in things like business information. Now, it can be on-site, can be outside, can be a cloud. I know some of you techies will say, we do not have SMF data on a Windows platform. No, I know we have to collect something that looks like SMF in order to get the same solution, the same setup, the same way of treating data, a huge amount of data actually. So how do we get into, how do we deal with the challenges here? How do we get in control by identifying, looking at the infrastructure, looking at the cost, and also how do we provide a business decision way where we supply data for the different levels in the organization. And also, we have to remember we must always use a common language so we get ourselves understood, us coming from the technical side. Reduce skill dependencies, meaning if we can push some of this data, this information into a self-service help desk, it will help us being in the techie side dealing with the remaining difficult problems. Securing efficiency, this is always an issue. We always have to work on return on investment. This is also the case here. So, what to be achieved when you have a system like this, an automated process? Transparency. You look through the usage of your system. You look at the numbers coming out. You do fact-based decisions on how things grow, how things decline, and how things develop. Efficiency. It would be nice to have a cutoff 10-15%. This is not always achieved in overnight, but if you can show your receivers, your stakeholders, what's driving your cost, when this is appearing, you can see magic happens and even workload moves away from the peaks to times where you have available resources. Cost effectiveness, meaning cost identification, cost reduction, and cost avoidance. This is also what you achieve when you have inside knowledge of your system and resource usage. I've promised my two co-presenters to talk a little bit about MIPS because it's used in the following slide quite a lot. So I made up, instead of a technical slide, a little bit about what is MIPS and where do we get it from. The CPU seconds is derived from the IBM System Management Facility. Many people use MIPS as a measurement unit, but you could also use CPU seconds. You could use MSUs. You may even use your own standards. However, for the coming slides, we use MIPS quite a lot. So, presenter, could you move to ODEN, please? Moderator. Pierre, will you make?
Yep, ODEN, if you can share your screen and you're unmuted.
Oh yeah, I have to share my screen. Okay, are we there? Okay, thank you, Carsten. We had some transition issues here. Hello, everyone. I'm very happy to be invited to present here. I do understand that this is only because Carsten thinks it is more convincing to have a customer telling about the advantages of IP, but anyhow, I'm happy. I work in DNB, the Norske Bank. We have about 2 million private customers, 200,000 corporate customers. In the marketplace in Norway, both both private and corporate, they are somewhere around 25 to 30% of the market. Since Norway is a small country, even if we are the largest bank in Norway, I would say possibly we are a mid-sized European bank. In staff, we are about 9,500, of which 830 resides in the IT department. My name is Elden Forbing. I work as a performance specialist in DNB. I'm a part of an exclusive 5-member group called APO, Application and Platform Optimization. I always get that wrong. I'm a Master of Science from the NIT, the Norwegian Institute of Technology, and then any confusion with the MIT, the institution in Massachusetts, must be strictly intended. I have worked as a performance specialist the last 15, 20 years. I used to work in a large international consultancy earlier, so I've been all over Europe, UK being one of the exceptions. So, what is the landscape, the system landscape in DNB? Like many banks, I would say we have a plethora of legacy systems over a score of partitions. When I started to write that sentence, I wrote it the other way around, and then I saw that plethora is a huge number and score is about 20. So we have a score of partitions. And then, when we have problems, either trend problems or specific problems, it may be challenging to find out where is the problem now. We have all the typical monitoring tools. Of course, we use SDSF, we have Detector, we have Timon. All of these are great tools for specific deep analysis of problems. Since I tend to say you may create the biggest problems in SQL, of course, Detector is the leading tool, but it's kind of digging tool. It's okay when you know where the problem is, but it is a little bit hard to really start from the top and find the problem. So then it is like I call it a day in life. And I can quote Paul McCartney, woke up, got out of bed, dragged a comb across my head. That was this morning. And, the distance from get out of bed and going into ITB is really short these days. I select to the right there, the selection is called Hyperdrill. I can never forgive SMT data and Carsten. Like it makes me feel like a nerd. It's the only thing I really use a lot, and they call it Hyperdrill. And I go into job and task, and then I get this picture, which gives me the MIPS consumption. It's quite useful to have it as a graph down to the left. This is like business hours 8 to 16 Monday to Friday. Why is that important? Because that is our payment model. We pay for the 95 percentile of usage from 8 to 16. I know that no two IBM clients have the same model for paying, but that is ours. So this is very important. Typically, the first thing I do is I look into a week and a day. So what is after the red line is a Friday, and then to the left of it is all the week up till that Friday and the Friday before. That gives me a good comparison. Is there anything abnormal? What we typically can see here is that Mondays are, of course, not of course, but in bank it is typically more traffic on Mondays. Also on the above here we have a table. Marked in reds are typically the 10 most MIPS using hours. So we see it is in the mornings, and on Monday we have several on the top peak. Okay, the 8 to 16 was quite normal. Nothing very interesting happened here. Then I can look at all hours. I tend to do that even if everyone tells me that whatever we use between 16 in the evening and 8 next morning are kind of, I have video on, free MIPS, I tend to treat it as really not free anyhow. Maybe the big issues are bad code is bad code, even if the MIPS is free. And the other thing is you risk that if you have a job using a lot of MIPS, on a top day, it may actually run into online time and thus create a what I call a billing peak. So what's happening here? Yes, I can see that on one of the days we are a little bit high, and then I can drill into that day. So now I have taken, okay, I've taken 2 days just to make sure to capture it. And I can see it is, yeah, there are 2 peaks, 8 o'clock and 23. Let's look at that at 8 o'clock. And now I have just 1 hour. What do happen this 1 hour? And, you know, after a while, you get a perception of what should this typically look like? Which processes, jobs should be on the top? So when I read this list, okay, this one at the top, that's normal. This is something I haven't seen before. And from the naming standard, this looks like a kind of batch job of a certain type. When I know that, and I know the peak, then I look into one of the more digging tools, and I can see a detector. Yes, it does have a peak at the same time, so probably this is something. I really like that, you know, the IPB data and what I can see later on in different monitoring tools, they should correspond. They don't do always, but you know, it makes me more confident when they do. And when I go into this interval, I see that it is a plant called DSNTAUL that takes 47% of the CPU. And this, as probably most of you know, is a standard package for having batch jobs run specific SQLs. So what I typically do here is dig further into it. This is not an SQL tuning course, I will not do that. And when if I get a suggestion or if I see what is the problem, I can go back and start discussing with the programmer. So this is typically the very interactive process you want to obtain. I mean, it is the programmers who make this, and they do errors from a performance point of view because they deliver functionality and they don't always look too deep into performance. Here is another case for IPB. We were in a fairly stable situation this summer, and suddenly we started to get some peaks. And that is especially a little bit surprising because during summer, as probably every one of you who works in banks and institutions like that, you introduce a freeze. You don't want to change the code, and all your specialists are everywhere. So no system changes was done, no specific large changes. But then, you know, from this material, we weren't able to find this in Detector or Timon. So we took this material and sent around to what we call the list of usual suspects. Yes, we do have such a list. And after a couple of rounds of nagging and, you know, finger pointing, a group stepped forward and said, oh, maybe it's us. It turned out that there was actually no changes, but they have put some extra traffic on some new interfaces. And here there was an error that made the interface query the source data several times for each transaction. You know, it's hard to see this functionally, because functionally it actually works. It gives the result they want, and they are happy. And they don't see necessarily such subtle changes as this. after all, it was 1,800 MIPS, and for those of you who knows these numbers, I would say for a small or mid-sized bank like DNB, 1,800 MIPS is not necessarily subtle. That's quite a high cost. So that was a couple of examples of how we do this work with this tactically, like from day to day or week to week. So let's look at the big picture. When I started in the bank 2 years ago, I got a report on my desk. Of course, we had increasing MIPS, all banks do. But the increase was much higher than what we could reasonably accept from or deduce from the increased functional traffic. So our group was kindly asked if we could turn our attention to this. So I looked at the ITB data and I saw that, oh yes, it does increase quite a lot. I have, as a consultant, often met this kind of situation. And then when it's important to bring CPU consumption or MIPS consumption under control, what you have to do is actually to find out quite quick which are the large contributors. Because if you optimize, if you find a system that consumes 100 MIPS an hour, and you take and you optimize it so 90% disappears, then you have saved 90 MIPS. If you find another system that has a consumption of 1,000 MIPS, and you optimize that a meager 30%, still you have saved 300 MIPS. So it's really important to find the large contributors, optimize those, and do not spend, working on your favorite well-known items. Do not spend time there. So here I turn to ITB. This is like what has used most CPU from Monday to Friday 8 to 16. Since that is what we pay for, that was the most interesting thing and the most urgent to get under control. Here I already see a pattern that gives me I become a little bit suspicious. QP something BRK, QA something BRK, QT something BRK. Being new in the bank, I had to ask what this is, and those were the brokers, the IIB processes in the bank. Some of the other shares you may recognize, I censor part of the database names. We have some KIXs, TCP IP process, yes, KIXs, but these were the brokers. There are about 1,500 processes down in this list in the business hours. So what I tried to do was to find out how large part is all the brokers. And here I could export it to Excel. Of course, it looks the same more or less with stripes. And I could do some filtering in Excel. And then I found out that this was 32% of the system. Average working days 8 to 16. And a chunk of the system, 32%, which you really haven't tuned a lot, that's interesting. But I think the key here was the flexibility of ITB to also let you say, now we have done as much as you can in ITB, put it over to Excel and do some more number magic is really good. So we were able to find out what we should work on. Then we have to go to ask for some money, and there you have to say we're going to do this, and the management was the results yesterday. Changes like this, especially if you are actually changing application code, may take weeks or some months, and it did for us. And then, then it's very useful to get some graphs on the way where we could say at this date we did something, Here we put a new version of an interface. Here we took away some logging. And with ITB, we were able to have graph numbers ready. And one thing which is very important is that without a tool like this, I've done that several times myself. You take out some numbers in January, then in March, you take out some new numbers of the same sort, and then you discover, oh, it would be interesting to have some other numbers as well, which you didn't extract in January. Whereas with ITB, it takes out a lot of number, and then if you decide later on, now it would be nice to have these numbers, you can have them. They're already there. So, what is the result after 1 year of work? Well, we have been able to turn a steady upward climb to a downhill. Also from this graph, you can see that in Norway, as opposed to most of Europe, July is the big holiday month. It's interesting, things like that. Anyhow, to do changes like this, there isn't a parameter, take away the MIPS guzzler from the IRB or something like that. There are normally a lot of changes. So we had some double format conversion. Everything was converted into XML because we thought that would be a useful intermediate format for an application to use. It was a good idea. It wasn't used. So now we said we drop it. We take away a lot of logging. Then we did also something. We discovered that we should restart the brokers regularly. Normally, I like to do changes that are elegant, that are somewhat intellectual demanding. This is ugly, but it works. So then it is like, okay, we do it. We saw that we used the brokers on the mainframe, which is an expensive platform, for some traffic going from one Unix platform to another Unix platform, and we decided this isn't smart. Also, we did things outside the IRB. In processes like this, there's typically a lot of things to do. We optimized a number of batch jobs that sometimes ran into online time at peak days. And peak days are the days when typically everything is in the roof. We found a couple of SQLs on the top list, which we decided we are going to optimize these. Some of them had been given up earlier, but we really gave it a push. And we also did some technical adjusting of partition sizes and priorities. So there are lots of things going into here. And then this graph is like also a result of 1 year. This is August to August. And this is quite revealing. We are 25% down. This is what I call close to a career changer. And this is the total MIPS. This is not the IIB or a selection. This is everything we use in the bank. It's 25% down. And if you see by the reds here, it is about, should we say 4,500 or maybe 5,000 MIPS. And those of you who have the responsibilities for contracts know that 5,000 MIPS, that's a lot of pound sterling or euros or dollar or whatever is your preferred currency. And also here is another way to look at it. This is for the September, and it still shows the trend. I think that it would have been hard to do this without ITB, because we used it in the start to just get an overview. Which is the largest process? To us, it was like in the brokers IIB. And note, everyone, when I say we had the issue in the broker, it is not as such the software from IBM. Be really aware of that. It is the way we used the software. It was the code we ran on the IIB. I have seen that quite often. You know, you get a new system software package. You get some DB2 and then you make things work and you do some not too smart things. And then after a while, you start to understand what can increase performance and you do it. And this was the same thing. So it's not the system software from IBM. It is our code, the way we use it. Of course, you know, we had hoped when we looked into this that it would be something in DB2 or Kix, COBOL. We know how to optimize that. But on the other hand, you know, there have been plenty of really good people working with this before I started in the bank. So they had done all those kind of things. So in one way that we discovered such a, should we call it a MIPS guzzler, in an area we didn't really, should we say, understand, or we really hadn't worked deep into, that was an advantage, because then we knew, okay, probably there is some factor we can trim away, since no one has done anything like this. Also, in the end, I would say that if anyone had told me when I started in the bank, okay, your job is to get away 25% of the MIPS consumption, I probably wouldn't have started, because it seemed a little bit far out. But this we were able to do with it. So I would, to summarize it to be a salesman for Carsten, is really, we identified the problem with a top-down approach. We didn't dig into our favorite areas. We could visualize things as we moved forward, and since this took time, and you know, management wanted the result to be present a lot earlier, that was fine. We had access to old statistics all along, so we could compare, and we could also bring up new aspects to compare, and we could document the gains. So that is about it. So I cannot guarantee that you will find 25% when you start doing this, but we didn't expect that either. So that is it for me. Then I should, let's see, should I stop share? And then I should give control to, where is you? Where are you? There, okay. You have control, Piara?
Arnie, if you just unmute and then share your screen. I've just asked you to unmute. Yeah, perfect.
Is it my screen or your screen going to show from?
I believe it's yours.
Okay. Do you see my screen now?
No, not yet.
Is this better?
Yeah, I think something's loading. Yeah, perfect. Can see it.
Good. Yes, I'm come from Posten Norway, and Posten Norway is a Nordic Postland Logistic Groups with the Nordic region as its home market. We meet the market with two brands, Posten and Bring, and you have probably seen Bring in the UK too, because we are represented there also. I myself is working as an application analyst on LM system. It's LM is abbreviation for logistic motor. It's a big system. I will come back to details afterwards. But I started in Posten in 1970, and then you can calculate my age. I've been working for more than 50 years. I was outsourced from Posten to the IT company Evry in 97, and I came back to Posten in 2014. And from that time I have been working as an application analyst. The logistic motor is a system that is responsible for supporting all the production processes in the Nordic area for Posten Norge and for all the Bring companies. On the map to the right, you see all the sorting centers we have in the Nordic countries. We have also production support for handheld devices. That is more than 14,000. We have delivery points where you can pick up your parcel. Typical is post offices, shops, parcel lockers. The system is known for all the integrations. It's more than 400 active integrations to other systems. And that is both asynchronous and synchronous integrations. Internal integration to, for example, invoicing, accounting, quality system, data warehouse. We have a lot of TMS systems we are integrated to. We have custom systems in the Nordic region. We have postal companies around the world, and we have customer systems we are integrated with. The main data in the system is all information about the parcels, and we are forwarding more than 100 million parcels a year. And on those parcels, we have a lot of production events. An event is telling what has happened to the parcel. For example, one can be handed into the Posten, it can be loaded on a truck, it can be sorted on a terminal, it can be delivered to the customer, it can be handed over to a delivery point, and it can be deviation events all through the production process. This we had against mainframe and ZOS solution, but we have moved it based on the CPU consumption. We have moved it to a set Linux platform. It's another partition on the same machine, but it's quite more, it doesn't cost so much. But we have a backup solution on the mainframe on the ZOS, so I will show it later. So this is where all the customers on the web can track their parcels and see what happens to them. Our vendors is Tieto Evry for application operations, and it's TCS, that is application maintenance and development. The system itself is a quite normal mainframe system. We are using SQL, PL, and COBOL as language. We are using DB2. We are using MQ and KIX. And the peak is on an ordinary day, we run 20,000 batch jobs. We have 250 online lookups per second. We have 200 MQ messages received per second, and this is in peak time, all of it. And Audun tell that it was only some of the hours in the day that was basis for pricing. But in Posten, we have an agreement that involves all the hours in the month. So here you see a matrix for September, where you see all the MIPS consumption in all hours. And we have a kind of agreement that says a 95 percentile of all hours in a month. And that means the 95 percentile, let us skip the 5% highest peak hours. That means the 36 highest occurrences. And we will be invoiced based on the 37 highest. And the 37 highest in September, that was 1,597 MIPS. So that makes us, we are not so influenced by bad situations when we can skip 36 highest occurrences before we end up on the invoice. How we work with IPI is we do internal follow-ups. The daily is based on the SMF data for the previous day, which SMT data has prepared before 8 a.m. in the morning, and then we can see the last day's MIPS usage. We are also using it for controlling or verifying deployments. We normally have deployment every second Sunday, and the following Monday is then very interesting to look into the MIPS. We also have historical follow-up. We have also to identify candidates for improving and tuning. We have a monthly technical health check report from SMT data. They have several experts on mainframe. They are looking into details we are not able to see, and they come up with good recommendation every month. So that is very valuable for us because we are not experts on the system software, for example. On the daily monitoring, I always start with the total workload. And most of the days, I can end monitoring with this graph because it shows no changes at all. It's exactly the same pattern as previous days. But when I come to a day when we have a deviation from the normal pattern, then we can see this example from 2000 as a normal MIPS usage per hour. We suddenly have got 3000 MIPS for an hour. And when I see the light green color, then I know this is DB2 resources, and I know from experience that this is DDF workload. And then I can dig into the DDF workload and find out that this procedure, SQL-PL procedure, has caused 60% of that MIPS usage. And it was this user that has done all the calls. And I can also see in which hours, because this is the backup procedure for the solution I mentioned. We have moved to the set Linux partition. But in September, on the 21st, they got problems with the data, so they have to rebuild their database. So then they had to turn the the tracking, parcel tracking over to ZOS and the backup procedure. And here we see some brutal numbers of MIPS. So we see for every hour the MIPS consumption for this procedure. And we saw that at 8 p.m. on the 22nd, they switched back to the set Linux platform. Then they have built their data bases from bottom from LM database. They have replicated the data. So this is one way. I also monitor daily the TSO users because they tend to forget the peak hours when they are doing SQLs from Spoofy and QMF. So I often have to remind them not to do that because that will influence on the invoicing. So in this case, I see this user has caused a peak, but that was a 1 day peak. It's not a normal behavior of this user. So I let him, I didn't address him at all for this one. But if I see a user that often is breaking the peak hours, then I will address the problem. The deployments I monitor with change detector. That is functionality inside the IPI. And here I see the Kix transaction. And here I compare last Monday with the previous Monday. And I see everything seems very normal, but except for one transaction. And that is this one that has increased 84% in MIPS usage. But that can't be explained by the growth in transactions. So in this case, I had to deep dive into the programs that run within this transaction. And that led me to a program we had to roll back that time. We also use change detector to see changes in the DB2 programs. And here we see it's a very good Monday. Almost all figures are stable, but I see one special thing that is odd. It's a reduction of 86%. And when I dive into historical data, I find this interesting pattern. And the history behind this was that the sanitation job had failed and didn't do the cleanup in a table. So this 50 job inserted 2 million rows every day, but it wasn't into an empty table, it was into a table that had all the previous days data. So that led to this specific pattern. But when we fixed the sanitation job, then everything went back to normal. This is another historic monitoring that caused us a lot of headache, because when we observed the MIPS usage through 2019 and into 2020, we saw a regression line that increased and increased and increased. And we took it up with, reported it to the outsourcer, to Tietoevry, but they couldn't find any reasonable explanation. But when we started to dive into it, first I'll just show that this is the peak for Black Friday and Christmas. So that is quite normal. So that is not part of the regression. But how I did analyze this, I looked into all the load. I had a suspicion that it was batch, so I looked in all load except batch, and that showed only a 50 MIPS increase for a period, and that is quite normal due to the volume increase in parcels and new functionality in the programs. But what I saw when I saw the batch load itself, then I saw a bad increase. And when I digged into all the batch jobs, I found out that 97% of all the batch jobs was okay, had almost no increase, but the last 3%, they represented two groups of jobs, 2 jobs with was rec step, and 5 jobs with was only running and submit step, nothing else. So it was quite abnormal that those kind of jobs that hadn't been changed for years should start to consume so much MIPS. This is the only step in the submit job. And when we look back to this, we can see the regression line now. We are back on track. Here I look into from September 2018 up to October 2020. And what really happened in this period where we had problems was I documented with the ITBI details and presented it for the outsourcer, and the outsourcer, Tieto Evry, brought it to IBM. And after some time, IBM came up with maintenance to the software. I think it was Yesto software. And the problem was solved, and it was brought back to normal MIPS consumption, the CPU consumption. So the conclusion is very easy. Without ITBI, we hadn't been able to present all the details in a convincing way for the outsourcer or IBM. And that was also the basis for our claim for reimbursement of overpaid MIPS for several months. And we succeeded with that. We can also look at the technical data in another way. And in the following slides, I will use a kind of business mapping. So this is showing KICS data, a technical way, but I have grouped all the programs, all the jobs, all the users into business areas, in top level business area, in lower level business areas, and in this way it's easy to get information presented in a form that is very easy to present for our management or for end users. So these examples show all the sorting processes done on the sorting centers. So here I can see how many transactions it's been run for the different sorters in the different area from the different vendors. So this is quite easy to communicate when we are meeting with the management, for example. I can also present the DDF in the same way. The top procedure in DDF shows 311 procedure. That is a validation procedure used by all handheld equipment to online validate the process, the parcel they are processing. So in this case, I can see this procedure is used for food validation. That's a kind of PDA. It's a product that is an Android solution, and a Scanit that is an Apple solution. So we have different ways to present it. So this is it gives much information for non IT persons within LM system. But how to succeed with this is you have to have a strict naming convention, because then it's much easier to group the programs and jobs to the different business areas. This is another way to, I will quickly run it, another way to see the same. And the lower bottom, you see the 311 procedure here again, in the same business area, but we can get it represented in this form. I'm not sure what you call it in English. It's a cake diagram or a pie diagram or whatever. But this is a good way to present it. And the summary of my presentation is, with ITBI, we got control. And if you guess where we got introduced ITBI in Posten, I think it's not difficult to see that. So before we got ITBI, you see how the MIPS evolved, and after you can see how stable it has become. And the peak you see after we got the ITBI, that is the Christmas and Black Friday peak, so that is quite normal. So that doesn't give me any sleepless nights. And the last file, the summary, shows MIPS pattern for the last 4 years. Here we see the problem where we had the software error from IBM. And this is the regression line showing we have an increase, but this increase I can explain based on number of parcels that has been processed in or produced in Posten and the Bring companies. And we see from 2017 we have moved from 1.5 million per week, and now in after this summer we have more than 2.5 million. And what we also can see is COVID-19 is to identify in this graph, because in week 14 we had the changes in behavior in Norway, and we see it's a lot of more net shopping that has increased the parcel volume with between 25 or 30% in our production, and that seems to continue all through, also into the Black Friday and peak period, and perhaps even bigger. So with ITBI we have got control, and we have had big and good results of it. And that was all from me. Stop share. Do I need to give you the command, Gino?
So are we at the end of the presentation now? Thanks to Anna. I'll just wrap up a few statements coming up here from the real life examples. We're talking about the IT and business alignment, especially the last slide here, where IT resources used match the business increase, the number of parcels. We saw from the first slides how we turn raw data into information suitable for IT operation, application development, IT finance, the billing, management, the high level information. produced in a way so it's understood by the receivers and you can act upon it. And when you have success in this IT business intelligence, not if you have success, but when you have success, you will see the graphics to the right. You will see how your baseline, your cost will go down, and you have a higher return on investment. We are now at the end of a presentation. So I started out talking about daily monitoring. I will end this presentation by talking about daily monitoring is your first line of defense. Back to the moderator.